try and follow me the best that you can.
Okay.
All right. So the first half at the top of the page should be fairly easy to fill in. So should the middle half, and then we will do some practice. All right, so number one, when solving problems that use proportions, it is necessary, that's the blank, necessary to make sure that all units cancel except for those in the answer. And we've been doing that this whole time. We wanted miles in the answer. We set this problem up so gallons would disappear magically. That's that magical number over a number equals 1. And 1 in math is our friend. I love multiplying, dividing, adding, subtracting 1. It's so fun. It's almost as fun as 0. All right, so the picket fence is a tool used to make sure that the units cancel. It's just a tool to keep track of my units so that I know when I can cancel them out. Now, did anyone set this up with this first and that second? Did you get the answer wrong? No, that's okay. But from now on, I want you to put the loner first. So when these get longer, if you don't start with the loner, you're going to be canceling out units that, yes, I might have something here, but the top might be all the way over here. Does that make sense? If you start with the loner, you're always going to cross out in this direction. And it's very orderly. All right, so when a number is on the top of the picket fence, it means the number is used to multiply other numbers by it. We've done that plenty. Now, when a number is on the bottom of the picket fence, it means the number is used to divide. What? Sue? Whatever, you guys just have dyslexia. Every single one of you, my friends. Mine says Sue. That's okay. All right, now let's look at steps 1 through 4 for using the picket fence. These should sound familiar if you've been here. Number 1, write out any proportions given in the problem and any others that may be of use. Got them? A lot of people look confused. Right here. Step 1. Write out any proportions given in the problem and any others that may be of use. Did we do that on our bell quiz?
Yes.
Yeah, here it is. Step 1. Write the proportions. And we did. We knew we went 23 miles every gallon. And then it says to include any other data that may be important. This was not a proportion, but it sure was important. Correct?
Correct.
All right. Step 2 says, identify what units are needed to satisfy what the problem is asking. So step 2, over here, we ask ourselves, what unit do I want? And what did we want in our bell quiz?
Miles.
Miles. I asked how far. Does that say anything about gallons? No. Is this true? Yes. Is this what I asked?
No.
Okay. I've had a couple of people, no one obviously did it in this class, because when they did it, they would say, I don't get it. Can't cancel anything out. Only put what is specifically asked for in the answer. Okay, step 3. Start the picket fence in the upper left-hand corner by filling it in with the number and the units that are not part of any proportion and is given to you in the problem. So remember, just simply, the loner goes in the left. Loner left. loaner. Got it?
You left the loaner, he's now on.
All right, and we had our loaner here, 5 gallons. We started right here, 5 gallons. Once again, if you did it backwards, it still worked out. Just do it that way from now on, so you can always keep track of the right units, so you can cancel them out. All right, finally, step 4, you fill in the picket fence from left to right, making sure to cancel the units as you go along. Remember, only when the same units are on the top and bottom of a picket fence do they cancel each other out. Okay, any questions? Let's look at our example. And yes, I require you to do these my way, or the highway. Okay, you're either do it my way or you're not going to get any points at all. Is that cool or what? Cool. All right, so if I read example number 1, I see that I have 23 marbles and they cost me $1.79. And then I want you to tell me how much 567 marbles cost, right? Step 1, I write my proportions. Are there any? What?
23 marbles over 179.
23 marbles for every $1.79. Is that a proportion?
Yes.
Yes. Did I include the units? Yeah, marbles and money, right? What other information was important? 567. Is that part of a proportion? No, that's my loaner, right? Okay, step 1 is done. Step 2, what unit do I want in my answer?
Dollar.
I'm going to write big so you can see it on the camera. I want, what is my unit? Dollars. So I ask how much would it cost? All right. Now, step 3, start here with the loaner. Top left, loaner left. What's my loaner? 567 marbles. Now, I always ask myself the following questions so I know which way this goes. And I say, self, are marbles in the answer?
No.
No, so I know marbles goes where? The bottom. So then what must I have in the top? Money. And I search my proportions. Do I have a money and marble? I sure do. How much money?
79.
How many marbles?
23.
I do a little math. Let's see, I can do this in my head. $44.13. Man, am I good. Oh yeah, I've already done it 4 times today. I am impressive. You guys go home tonight and pray that I'll find humility around. I really am. I'm the most humble guy I've ever met. All right. Turn to page 22. Does this look like something you could do? Would you like me to help you with number 1? All right, let's do it. It says, solve the following challenges using the picket fence format. Make sure to show all of your work and label and cancel all of the units. So number 1, Katie Cantor, $9 for working 2 hours. How much would she earn for working 5.5? Does that sound like it has a proportion in it? Sure does. What's my proportion? Okay, if I work 2 hours, I earn $9. Is there anything else important to that problem? Yeah, I need a loaner, don't I? What's my loaner? 5.5 hours. Both of these were given to me right in the problem. Step 2, what do I want? I want money. Who doesn't, right? Step 3, where's my loaner? You tell me. 5.5 hours, right? Must be the video camera, right? Is hours in my answer?
No.
No. So they better be down here. What must be up here then?
Money.
Do I have a proportion that fits?
Yes.
Yes, right here. Oh, I better flip it over. Is that legal?
Yes.
Oh, you bet your bottom $9. Okay, then I do some math. 5.5 hours times $9 divided by 2. Carry the 1, square root that. 24, 13.
No.
75.
Dang it. 75?
Yeah.
Yeah. 13.
There's a 13 in here somewhere.
Our last problem.
Oh, yeah. Thank you. All right. You do the rest. And units of numbers. All right, number 3 says, a big fat black marker, there it is. It says that Mr. Sanchez paid $345 in taxes for his lot, which was valued at $65,000. At the same rate, what is the value of Mr. Gomez's lot, who paid $468.75 in taxes? So what's my proportion? 345 what? Tax. Good. You have to distinguish between tax and the $65,000 value. Wow. Someone nailed it right on the head. Good work. All right. What's my loaner? 468.75 tax. What do I want in my answer? Moving over to step 2. I want value. All right, what's my loaner? 468.75 tax. Do I have tax in my answer? No, tax down here, and I must have value up here. What's my proportion? I have 345 tax for every $65,000 value. If I do that, I get 88,000. I don't remember. $315. Fair enough. Let's check your other ones. Number 2, what did you get? 6.64 gallons. Number 4, it depends on you. You're 5'11", you're 180 centimeters tall. Number 5, what did you get? All right, 1.22 meters squared. Number 6, how many donuts? 34. You have 0.29 of a donut. I guess you could. They probably won't sell it to you. Who's gonna eat the other 0.71? You already had a bite out of it? Weirdo. Okay, how hard are those? 1 to 5, 5 being hard. 1 or 2-ish, hopefully. Okay, let's complicate matters. Okay, turn to page 23. Now we're going to apply this to chemistry. We're going to talk about the warm and fuzzy mole. Nothing's better than a fuzzy mole. We all have them. Okay. So here we go. Chemists, these are your notes. Chemists have devised a means for keeping track of the amount of matter involved in chemical reactions. This method uses the gram formula mass, better known as the molar mass, or mole for short, M-O-L-E. And that is the shortest way to write moles. There is no M for moles. That's already taken. Sorry. Because mole is already short. It's gram formula mass or mole. Okay, just for your information, get my trusty pointer out. This is what a mole is. It's not that brown fuzzy thing behind my ear. 1 mole is 6.02 times 10 to the 23 atoms or molecules or whatever. If I said I had a mole of pennies, would I be rich?
Short.
Would I be tremendously rich, moderately rich, or I'd be alright? I'd be so rich I'd have more money than anyone ever in the entire universe. Because, look at this number. Okay, let's change it to dollars. That's how many dollars I have. Is that enough? That gives me by. I'd be alright with 6.02 times 10 to the 21st dollars. That would take up a warehouse bigger than you could even imagine. Another way to reinforce that number. If I had this many starbursts, could I eat them in my lifetime? No way. Not a chance. If I had that many starbursts and every person in the world was eating them, could we ever eat them?
Yes.
No.
No.
Why?
Because every one person would have to eat about that many starbursts.
I can do it.
That's a lot.
Until they're all
Forever.
gone.
1, 2, 3. 1, 2, 3. 1, 2, 3. There's a billion that way. 1, 2, 3. There's 100 billion. So you got 602 billion. So 602 trillion. That'd be a lot of eating. That's a lot of yellow. I mean, if they were all pink, I'd be alright.
Yellow. Totally yellow.
You like the yellow?
I love
Yellow
yellow.
and orange.
I don't mind
Like the
more.
ones that are
Yellow.
left.
You should be taking
The
out
ones
that.
no one doesn't.
I eat them all because everyone else doesn't.
What's that G saying in the world?
So you're smart.
Yeah.
You get all you want. And they fight over the pink.
Yep.
Alright, so basically in a nutshell, one mole of anything is a lot of whatever it is. Okay, one day I was really bored. So I counted out that many atoms of carbon. Then I put them on the balance, and I discovered that they weigh 12.0111 grams. Is that a lot of weight or a lot of mass? No. This right here weighs more than 12 grams. So you're telling me maybe like this lid full of carbon would be that many. What does that say about the size of an actual carbon atom?
Small.
They're really
Itsy bitsy teeny weeny.
Okay, follow along here. So, 1 mole of carbon, I counted them out to 12.01 grams. So I could write 1 mole of carbon is 12 grams, right? Or I could write a proportion. So that every 12.011 grams, I have 1 mole of carbon. What if I wrote 1 mole of carbon over 12.1011 grams? Same thing. All right, honestly, I didn't count out that many. I just looked on my periodic table and the number was already there for me. Isn't that neat?
Wow.
You bet. What's the molar mass of magnesium?
24.
24. Zirconium?
91.
91. What do these numbers all have in common compared to the other number in the box?
They're bigger than
They're bigger. The molar mass is always the larger number in the box. Always. Now, let me warn you, in some periodic tables, the mass is on the bottom. And in others, the mass is on the top. Don't say it's the top number. Say it's the larger number. All right, let's fill in some blanks here. In each element box in the periodic table, there are two numbers. The molar mass of an element is the larger of these two numbers. For example, the molar mass of carbon is 12 grams per mole. Rounded off, of course. All right, take out your periodic tables and see if you can find the molar mass of each of those. Cut. All right, let's take it one step farther. Remember the show, What About Bob?
Yeah.
I love that show.
Baby steps.
We
Okay?
got that for you.
I know none of this is hard, and at the first you hate it. In fact, I love my A's because they always have strong testimonies of chemistry. She said at first I hated this, but what did you say?
It will save your bum in the end.
These aren't very hard. I can do this in about 30 seconds.
Got it.
But at the end, they are very long. Okay, so we know how to find the molar mass of an atom. Let's find the molar mass of a molecule. Don't worry about it. You're on tape. Believe me, I'm cool with that. All right. So.
Dang, I missed it.
Coming back.
All right, so how can we find the molar mass of a molecule, like water? What do you think we have to do?
You add an H1 and H1 and then O1.
Okay, there's two H's, so I better find the mass of two H's and add them together and then add what?
An O.
The mass of one O. Not too difficult, right? All right, so look down. It says, to find out what the mass of a molecule is, remember, a molecule is more than one atom joined together. You must first count up the different types and kinds of atoms. For example, CuSO4. We're going to break that down. We want to know how many coppers are there? How many individual coppers? All right, 1 Cu. How many S's?
1.
1 S. How many O's? Love this room. All right, earlier the all pass thing just fell down all of a sudden out of nowhere. Okay, so I write OX. Why would I put OX? So that it doesn't look like a 40. That makes sense. If I just put 4 O's, that in your mind is 4T. You know what T is like? No. Okay. So, the latest
A little bit of chemistry humor there.
So you put a what by the copper atom, a what by the sulfur, and a what by the oxygen? 4. All right. That is a piece of cake, right? So let's do it together. Number 1, count up the number of types of atoms of the following molecules. How many H's are there at H2?
2.
Whoa. 2. Number 2, AlCl3. How many Als are there? 1. How many Cls?
3.
3. You see how that little number to the right gives it away? Holy cow. How about 3? C6H12O6. How many 6s? The C's. How many
6.
C's? There are 6. How many H's? 12. How many O's? 6. That was easy. Now let's see if you know how to figure number 4 out. How many CAs are there?
1.
1. Not 2. Although no one guessed 2. First hour. This is the first hour no one has, is what I'm saying. All right, how many N's?
2.
2. Just N's. Ends. The little 2 outside the parentheses applies to everything inside.
the parenthesis.
But the O, the 3 with the O only refers to the O. Right. So how many O's are there then?
6.
6, not 5. There's 2 sets of 3. When we have 2 sets of 3, we multiply 3 by 2. We don't add 2 to 5.
Your fingers and numbers matched up nicely.
I've overcome that. I haven't had that problem all year.
Except that one time you did.
Oh, I did?
You didn't know our class once. Just once though.
Oh well. It's always dreams.
And I shattered.
Next time I'll get it. All right. So now it says next, comma space. No, that's space. Multiply the number of each type of atom by the molar mass of that element. For example, okay, so we want to find the total mass. We found out what it was consisting of, and now we just have to find the mass of each one of those and add it all together. Did I say that too fast?
No.
Yeah. Kind of look down here. Good. All right, so I have 1 copper. What's its molar mass? 63.5. All right, I'm going to add that to 1 sulfur. What's its molar mass? 32. Plus, I have 4 oxygen. What's its molar mass?
16.
16. Okay, 1 times 63.5 is 63.5. Plus, 1 times 32 is 32. Plus, 4 times 16 is 8 times 8. We all know that. That's 64, right? I add that together. I get 159.5. Is there a unit? You better. What is it?
Mole.
Grams per mole of what? I can't stress to you how important the units become in stoichiometry. So you need to write this whole thing out, because in a long problem you're going to have moles of CuSO4, moles of H2SO4, and moles of something else. If you just write mole, you're going to have 3 different types of moles. Remember the tax? It's all money, but we need a tax and value to make sure we got it straight. Turn over the page. I will help you with one of them. Choose wisely. What one would you like me to help you with?
The bottom one.
The bottom one, okay. 2 classes you said, number 1. Sweet. That takes 10 seconds. All right, so we're going to solve the bottom one. Come back over to this part of the board. The bottom one, what is my molecule? CaNO3 2. Now, just for the future, this does not equal CaN2O6. Number-wise, it should, right? But in 30 seconds or less, that doesn't exist because calcium can only bond in 2 places. It bonds to 2 separate NO3s. This says that calcium bonds itself twice to nitrogen and 6 times to oxygen, which means it would have to have 8 places to bond, and that doesn't exist in our universe. So, notation in chemistry is extremely important. All right. Is that longer than 30 seconds?
Yeah, that's pretty good.
All right. How many CAs do I have? We've already figured this out. 1 CA. How many N's do I have?
2.
2 N's. How many O's do I have? 6 oxygen, right? All right, now the next step is to multiply this number by the molar mass. So 1 times, what's the mass of Ca?
40.
All right, plus 2 times, what's the mass of nitrogen?
14.
Plus 6 times the mass of oxygen. 16. That is all going to be my molar mass, right? Do I mess up? Okay. I have 40 plus 28 plus 96 equals 164 grams per mole CaNO3. See how to do these? Okay, finish the rest. On H2, what's the molar mass? 2 grams per mole. 2 AlCl3. 133.5 grams per mole, AlCl3. How about number 3? 180 grams per mole of sugar. That's what sugar is, C6H12O6. Number 4, we already did 164 grams, right? Okay, good. Now you know how to construct a proportion for the molar mass of a substance. What do we put proportions in? Fractions. The picket fence. So there's the next blank. We can use this proportion with the picket fence to calculate the number of moles or the number of grams in a quantity of a substance. For example, we have 2 examples figured out for you. Finally, the picket fence and science. All right, so here we go. Number 1. This is the type of problem we will be solving. This is the easiest type of problem that we will be solving. Number 1. How many moles are in 26 grams of H2? I see in my lab book that the molar mass, that's my proportion. Was it given to me? No, it wasn't. We had to figure it out. It was 2 grams over moles. All right, there's my proportion. What was my loner? 26 grams, so I plug it in. 26 divided by 2 is how many moles? 13 moles of H2. That's your blank. All right. Number 2, how many grams are in 2.1 moles of AlCl3? Well, is the proportion given to me? No, I had to figure it out. It was 133.5 grams per mole. What's my loner? 2.1. I do the math, I get 280.4 grams. So it's 133.5 is the blank. Look at number 3. I will help you on the next page. How many moles are in 107 grams of C6H12O6? Step number 1, what do I do? Always, I write the proportion. Was one given? No, so I have to find the molar mass of sugar. But I already did on the previous page. What was it? 180 grams per mole. Do I have a loner? What is it in the problem? Read the problem. 107 grams. Step 2, what unit do I want in my answer? Moles. Step 3, I put the loner right here. What's my loner? 107 grams. Then I ask myself, what question? Is grams in the answer? No, so I got to get rid of it. I better have moles up here then. That's what I do want in the answer. Grams gone, but let's fill in. Oh, hey, there's a proportion that fits that style. 180 grams for every 1 mole. And I take 107 and I divide it by 180. I don't remember that answer. 0.59. Oh, I do remember that one. Moles of C6